You guys are starting example 2, which is very similar to example 1, except now we're dealing with a jet that is flying from Los Angeles to Mumbai, and there's this wind in the air that is affecting how fast your little jet can go. So our little jet's going, and the wind is either causing it to go faster if we're going with the wind, or if we go against the wind, it will influence the jet, and the jet won't be able to go as fast. So we have to keep that in mind when we solve the problem. So a passenger jet travels from Los Angeles to Mumbai, India in 22 hours. The return flight takes 17 hours. The distance from Los Angeles to Mumbai is 8,688 miles. The difference in flight times is caused by winds over the Pacific Ocean that blow primarily from west to east. If the jet's average speed in still air is 550 miles per hour, okay, so that means without any wind influencing it, that's how fast the jet can go. Okay, what is the average speed of the wind during the round-trip flight? We're going to round that answer to the nearest tenth. Let's get going. All right, so in the problem, we want to find how fast this wind is blowing that is either making our jet go faster. When the jet's going with the wind, it goes faster. When it goes against the wind, it goes slower. So our wind in the problem, I'm going to denote with a W. So if you see a W, I'm talking about the wind. All right, let's get to labeling. So a passenger jet travels from Los Angeles to Mumbai in 22 hours, and the return flight is 17 hours. So for our total time, okay, one way it's 22 hours, and on the way back, it's 17 hours. So our total time, we need to add those bad boys together. So 22 plus 17 would give us a total time of 39 hours in the air. That's a long time, you guys. Hopefully you never have to fly that long in the air, because that kind of is a little obnoxious. All right, but anyways, let's keep going. Okay, and the distance from Los Angeles to Mumbai is 8,688 miles. So our distance here is always going to be the 8,688 miles. No matter how long it takes us, that's how far we travel to get there and to get back. So our distance in both cases will be that 8,688. 8,688. Technically, it's miles, so if you want to write miles, you can. All right. All right, now our rate, this is how fast we go through the air. So the differences in flight times is caused by winds over the Pacific Ocean that blow west to east. Okay, which even if you don't know, like when you go from Los Angeles to Mumbai or Mumbai to Los Angeles, which way is west to east or east to west, I have another trick in the problem that will help you figure out which rate is going with the wind and which rate is going against the wind. So it says if the jet's average speed is in still air is 550 miles per hour. So our rate is going to start off with 550 miles per hour. Okay, which I should have done this one in blue. Trying to keep my colors coordinated. Sorry, guys. All right, that's me being OCD. So our rate in both of these cases starts off without the wind as 550 miles per hour. So 550 here and 550 here. Now the tricky part is figuring out which one is going faster. Because remember, like in this problem, the current, for the faster one, we had to add the current because that would give us a larger rate. And for the slower rate, we had to subtract the current because that would give us a smaller number. Okay, so let's think about this. It says from Los Angeles to Mumbai, it's 22 hours. Okay, from our return trip, so from Mumbai to Los Angeles, it's 17 hours. So it seems like when we come back, the wind is going with us because it didn't take as long. But it seems like when we go there, it actually takes an extra 5 hours because we're fighting the wind. So when we're heading to Mumbai, we're going slower. So let's think about what do we need to do to 550 to get a smaller number since our rate is going to be slower. You guys are so smart. We would subtract the wind because when we subtract something from a number, it gives us a smaller number. And if we're fighting the wind, we're going to be traveling at a slower rate. Okay? And the opposite would be true for Los Angeles. So Los Angeles, it only takes 17 hours, which means our plane is traveling with the wind, which means the wind will be pushing the jet faster and faster. That's why it takes 5 hours less time to go on the way back, which is pretty awesome. Okay, so since our rate is faster, we would have to add the wind to it. Okay? All right, let's set up this fraction. So our fractions, we put our distance over our rate. So let's get going. So I'm going to have this 8,688. Going to write small. Over this 550 minus W. So 550 minus W. I know that's hard to see. 550 minus W. All right, and then this one is the same thing. I'm going to put my distance over my rate. So my 8,688 over my 550 plus W. Okay, so now that we have this information filled out, let's go ahead and set up our nifty formula, which is our total time plus the time it takes to go against the wind and the time it takes to go with the wind instead of downstream and upstream. Okay, so let's set this up. So we're going to have our 39 equals, and it honestly doesn't matter which one you guys put first, but when we go against the wind, it's to Mumbai. So I'm going to write that one first. So 8,688 over our 550 minus W. All right, and then plus our second fraction, which is the 8,688 over 550 plus W. All right, so after this, you guys, it just turns into a rational equation problem. Now, this one, the toughest part about this one, you guys, well, setting it up is kind of tough. That is a tricky part. But after you set it up, this one's going to be tough because if you see here, we have big numbers. But I will allow you to use your devil device on these problems. So if you need to use it, it's okay because the numbers are going to get really big and really obnoxious. All right, so our LCM, if I grab one of every single factor I see out of my denominators, my LCM would be 550 minus W for this one, times my other one, which is 550 plus W. So that would be my LCM. And then my undefined, we set each of these bad boys not equal to 0. Okay, so let's see, kind of out of space. So we set 550 minus W cannot equal 0, and 550 plus W cannot equal 0. All right, let's solve this thing. So in this one, you guys, the easiest way to solve would be to bring the negative W to the other side to make it positive. So I'm going to add that thing, plus W, cancels out and turns to 0, and 0 plus W is W. So on this side, we'll say W cannot equal 550. Okay, so if we get that as an answer, it's not allowed because we'll make our denominator 0. And this one, you guys, the fastest way, since my W is positive, would be to bring the 550 to the other side. So I'm going to subtract that thing on both sides, which 550 minus 550 cancels out and turns to 0. And W cannot equal 0 minus 550, which is negative 550. Okay, so if we get these answers in our problem, either 550 or negative 550, they will not work because they'll make our denominator 0. So be on the lookout for that. All right, well, let's start solving. Got a lot of algebra to do, so let's go. All right, the first step, we multiply every single numerator by our LCM. Let's hope I can leave enough space this time, which I'm just going to write all this in one color. All right, so I'm going to have 39, let's see here, equals 8,688 over 550 minus W. And remember, I'm leaving space for that LCM. 8,688 over 550 plus W. Okay, so now I'm going to multiply the LCM to every single numerator I see, and the goal is to get rid of these denominators. So I'm going to multiply this bad boy by 550 minus W and 550 plus W. See, I'm running out of space. Sorry, guys. All right, 550 minus W and 550 plus W. All right, and again, 550 minus W and 550 plus W. All right, let's see what will cancel out. Okay, so nothing cancels out here, so I'm just going to bring it on down. So we're going to have 39 times 550 minus W times 550 plus W equals, now, let's see if anything crosses out on this side. Holy hot dog. Look, my 550 minus W will cross out. Bam. And I'm left with 8,688 times 550 plus W. All right, on this side, the 550 plus W will cancel out. Bam. So I'm left with 8,688 times 550 minus W. All right, you guys, let's keep going, keep going. All right, so now all we have to do is a bunch of distributing and a bunch of adding and subtracting. And I'm running out of space, so I'm going to keep going on this other sheet of paper so I don't run out of space and make everything all cramped up and hard to read. Okay, so let's start solving this thing. So on this side, you guys, before I can multiply the 39 through, I need to distribute all these together. So let's get going. So I'm going to bring down my 39. Sorry, guys. Need to organize my space. All right, so 39 is going to distribute to each of these. Or no, sorry. No. Don't do that, don't do that. Whoa, Miss Long, stop. So I just told you not to do. Jeez, Miss Long, get with it. Sorry, I'm going to leave my 39 there, and I'm going to distribute these two together. Okay, now let's get going. And everything I distribute, I'm going to put in this parenthesis. Okay, so 550 times 550, well, that's going to give me 302,500. All right, and then 550 plus W will give me plus 550W. Negative W times 550 will be negative 550W, which I definitely didn't leave enough space. Jeez, Miss Long. And then negative W times W will give me a negative W squared. All right, let's keep going. All right, on this side, I'm going to distribute my 8,688 to both of these items. So 8,688 times 550 will give me, let's see here, it will give me, I'll just multiply it out on here so we don't waste time multiplying all that together. All right, so I'm going to do my 8,688 times 550. And that will give me that big number. All right, so we have 4 million, holy hot dog, 4 million, let's see here. Yes. Okay, so we're going to have 4,778,400. Holy hot dog, right? Okay, so 778,400. Told you these numbers would be quite large. All right, and then 8,688 times W would be plus 8,688W. All right, and then the same thing on this side, which I'm going to write it, whoa, sorry guys, let me get my life together. All right, I'm going to do the same thing on this side, but I'm going to run out of space, so I'm just going to write it underneath it, so just be careful, you guys. These big numbers are taking up a lot of space. So I'm going to distribute these to each number. So 8,688 times 550, like before, will give me all that. So plus 4,788 or 778,400. And then 8,688 times negative W would give me a negative 8,688W. Okay. All right, so now let's keep going. I'm going to move that problem out of the way because it's getting in my way and it's irking me. Okay. All right, let's keep going. So now I get to distribute 39 to all this lovely stuff. But before we do that, let's combine our like terms. Okay, which I see I have a 550W and a negative 550W. So guess what, you guys? They will cancel out. Bam, bam. Okay, so in this one, I'm left with 39 times 302,500 minus W squared. All right, on this side, let's start combining like terms. So I'm going to have these two added together, my 4,778,400, which when you add these together, which I'm just going to simply multiply what I had times 2 on my calculator to save some time. So times 2. It's going to give me all that. So 9,556,800. Jeez Louise. Getting big in our numbers. So 9,556,800. And if you see here, you guys, these two are going to cancel out. Bam, cancel out. All right, so now our numbers, or our equation at least, is starting to get smaller. So now I get to distribute the 39 to each of these numbers. All right, so 39 times this super large number is going to give me 11,797,500. And 39 times negative w squared is negative 39w squared. Equals all this, so 9,556,800. All right, let's keep going, you guys. And again, it's not a hard problem, it's just these numbers are quite obnoxious. All right, so let's solve this thing for w. So first, I need to move this large number to the other side. So I'm going to subtract it on both sides first. Which this side will cancel and turn to 0. And we will be left with negative 39w squared equals, let's see, when we subtract those two, we'll get negative 2,240,700. All right, which I'll double check, but I'm pretty sure that's right. So minus 11,797,500. Bam, yes, precisely. Awesome. All right, let's keep going. I need to move this negative 39 to the other side. So the way we do it, since it's secretly multiplying to my w squared, is by dividing both sides by that bad boy right there. All right, which on this side will cancel. So we're left with w squared equals whatever that is divided by negative 39. So under nifty calculator, divided by negative 39 will give us 57,453, and I'm just going to round to the nearest decimal since that's kind of what the problem told us to do. All right, so it would be 0.8. Okay, so we have 57,453.8. All right, guys, we're so close to being done. One more step, or actually two more steps, and then we'll be done. This is so much fun. I love doing problems like this. All right, so the way that we undo a square is by square rooting that thing. Which the square root will cancel out our squared. So I'm left with w. Now remember, whenever we square root both sides of an equation, we get a plus or minus. So plus or minus the square root of that number, which you can use your calculator. Remember, the way we get a square root on your calculator, see this nifty blue square root above the x squared? That's where it is. So you hit second x squared. So second x squared, and bam, that will pop up. So we're left with 57,453.8. And that will give us 239.7. Bam. But remember, you guys, it does not make sense to have, well, we have a plus or minus, but which one of these values does not make sense? You guys are so smart. It is the negative one. So my answer will be the positive one. So our wind speed is going really fast. Holy hot dog, that's super fast. Our wind speed is traveling at 239.7 miles per hour because our original rate, if we look back to the problem, our original rate is in miles per hour. So yay! That would be our answer. But before we circle it, let's double check our undefined. Our undefineds are 550 and negative 550. So yay, it's none of those. So that would be my final answer. Yay! That was awesome. Alright, so again, I hope you guys enjoyed this problem. It wasn't a tough problem. It was just really big numbers, and Miss Long was being obnoxious with her two papers for a little bit, so I apologize about that. Alright guys, well I hope you enjoyed it as much as I did.